Good evening, everybody, and once again, welcome back to the video. Today, I stumbled upon an amazing article on Uber engineering blog, which is setting Uber transactional data lake in motion with incremental ETL using Apache Hudi. So I'll try to summarize this article over here, and if you need, please feel free to go to the actual source and read more. Thank you to the author, Mr. Vinod, Mr. Saket, Mr. Yogesh and Ayush for publishing this article and making the information available to the public. So let's get started. The global data warehouse team at Uber democratizes data for all Uber with a unified petabyte scale centrally modeled data lake. The data lake consists of foundational facts, dimensions, and aggregate tables developed using dimensional data modeling techniques that can be accessed by engineers and data scientists in a self-serve manner to power data engineering, data science, machine learning, and reporting across Uber. The ETL, extract transform load pipeline that computes these tables are thus mission critical at Uber's app and services, powering core platform features like rider safety, ETA prediction, fraud detection, and much more. At Uber, data freshness is the key business requirement. Uber invests heavily in engineering effort that process data as quickly as possible to keep it up to date with what's happening in the physical world. Challenges. In order to achieve such data freshness in our ETL pipelines, a key challenge is incrementally updating these model tables rather than recomputing all the data with each new ETL run. This is also necessary to operate these pipelines in a cost-effective and an Uber enormous scale. In fact, early 2016, Uber introduced a new transactional data lake paradigm with a powerful incremental data processing capabilities through Apache Hudi project to address these challenges. Later on, Uber has donated this project to Apache Software Foundation. So let's take a look at two use cases which is given on Uber's engineering blog, which is driver and courier earning and frequent menu updates for Uber Eats merchants. Again, these are classy use case on how they have used incremental data processing pipelines. So let's take a look at the driver and courier earning. So one of the common thing basically is whenever a driver would complete a trip, right? Let's say the driver made about $10. Tomorrow, you can tip the driver, and basically you now have to update the earning of a driver. So if you see in the diagram, on Monday the driver made $10, but after tip, the tip is basically a late arriving update. So you wanna update the base pay, right? So basically, if you see on the image over here, the base pay was updated to $11. Now, traditionally, take a look at this. In typical batch ETL, we would have no intelligence on how the input has changed, right? We would assume an end day lookup, right? An end day look back and reprocess all the partition updating driver earning wherever necessary to the target table. So basically, you would take just like 30 days or 60 days, and you would just reprocess the data. Again, in terms of cost, it's expensive and it's time consuming too. I mean, think about the scale at Uber, right? How much data would they have, right? So this proved to be a very time and resource exhaustive process, as there could be a very small number of records to update in a partition which are month old, which makes sense. So that's where Uber started using incremental pipelines using Apache Hudi, right? So with incremental pipelines, they achieved about 100% data accuracy and completeness. So again, a classy use case of using incremental data processing pipeline. So you don't need to run that entire months or entire months. So basically, you don't need to run that end day look back basically, right? So now you can just run the pipeline basically on an interval, and it's gonna basically pull up incremental updates, and you can perform an upsert now, right? So again, very nice use case, right? Frequent menu updates for Uber Eats merchants. Okay, let's read this. Another use case where incremental reads and upserts win over batch processing model in both performance and cost is when we need to cater the frequent updates and get the data into our model tables with short SLAs. So here they explain example of restaurants menu, right? So the customers or on Uber Eats, right, when you order food, right? So the people, the restaurant people, right, they can change the menu, they can add new items, they can remove items, they can do that, right? So there are a lot of updates which are happening. Now, one traditional way to do is basically at the end of the day, you would just process the entire day of updates, and basically you will perform an updates, right? So again, so here they actually say that the batch processing of catering to this use case is to pull the whole day changes at once and then merge this against the latest state of each existing record to get the latest picture for all the entities, and then use this information to populate all the other tables. Now again, think about it. At the end of the day, you're doing an entire big batch processing. If something failed, it can further add more SLAs, right? And also it is in terms of cost as well, right? It's not the best, right? It's very time consuming. Uber basically gives you some number here, and these are pretty amazing to see. So about if you see the percentage of entity updates coming in per day is significant fraction of total number of entities, which is 408 million delta commits as compared to 11 billion total entities. So again, definitely makes sense, right? So here also they implemented the incremental pipelines. So incrementally pulling these updates and basically performing upsert. Again, a great way. They also reduce the SLAs, right? So the last thing that I want to show you, again, you can come and read more, is this one, right? Cost savings and performance, right? So if you observe, they were able to get about 78% improvement in the cost, 80% improvement in the runtime, 73% improvement in memory seconds. Again, you can go over these stats and it's simply flawless, right? Finally, I just want to conclude the video. With help of Apache Hudi and Incremental ETL, we can read the updates incrementally and only run computational logic on the delta changes and then upsert the record into our Apache Hudi data lakes. There are many advantages that incremental data processing model brings to the data engineering community, including large resource saving, lower data freshness, and optimal data completeness, and while allowing downstream workload to follow a suit. In fact, this is one of the rare opportunity where Uber was able to reduce the cost of the system while enjoying the increased performance, right? Again, it's a very nice article. If you get a chance, I strongly encourage you to come and read it. Again, there is much more given on this article. There are stats given that you can read. Again, amazing article, posted on their blogs, right? And these are the authors. So thank you so much, guys, for sharing such amazing, articles to the community. And please feel free to go to the links. I'll be providing the links in the description if you want to read more. Again, great way how they were using incremental ETL, basically for two use cases that they gave in the article, right? I think the one of the use cases were, for example, the driver and the courier earnings, and the second one they gave was frequent menu updates for Uber Eats merchants. Thank you so much for watching. I hope you have really enjoyed, and if you want to dive deeper, please go and read the articles. It's really nice article. Thank you, and I'll see you in the next video.